The RCUK Energy Programme is working towards meeting the government targets of an 80% cut in carbon dioxide emissions by 2050. And it's doing this by working with the academic community and nurturing and enabling new ideas and new research to come forward, which will allow those targets to be met. The programme is focusing on making certain we have the right supply of scientists, engineers, social scientists and economists to allow us to deliver high-quality research that's relevant to the global energy challenge. The energy programme involves the EPSRC, the ESRC, NERC, BBSRC and STFC. The RCUK Energy Programme works with over 500 public and private partners, ranging from public organisations like the Technology Strategy Board, the Carbon Trust and DEC, and private organisations like Rolls-Royce and E.ON. We have a lot of programmes on carbon capture and storage. We have a programme looking at solar, big programmes on nuclear energy, on smart grids. These are just some examples of the research activities, as well as my own research area, which is fuel cell technology. The investments made by the RCUK Energy Programme will allow the UK to compete in a global economy where we have to tackle these challenges of energy security, affordability and sustainability.
The UK Energy Research Centre has a special place, I think, in the Research Council's energy programme, because we were set up about 5 years ago to take a whole systems approach to energy. Some people might look at one bit of the energy system or one technology, like carbon capture and storage or nuclear. What we're asked to do is look at the energy system as a whole and how the different parts interact with each other. We have divided the work into 4 different themes. So one of the themes is looking at energy demand. There's another part looking at energy supply and infrastructure. We've got a theme on energy and the environment, where we're looking at the environmental impacts and consequences of different paths of development for the energy sector. And then we have a final theme that is called energy systems, which really is the people who try to put it all together, mainly by using big computer models that try to simulate the way the energy system operates. We're asked to take a whole systems approach, so we're funded by the Engineering and Physical Sciences Research Council, the Natural Environment Research Council and the Economic and Social Research Council. And that means that the UKERC people are actually coming from a very wide range of disciplines. And a number of the people who are involved in UKERC have actually carried out contracts for, say, the government or the Committee on Climate Change to help them with their analysis. The biggest challenge really is getting an energy system that's compatible with a world in which climate change doesn't run away with us. It's a challenge that will never go away. We've got decades of work to actually carry out here. It may go in and out of fashion as time goes on, but for the kind of PhD students that we are bringing through at the moment, we hope it's still part of their professional life, when they're as grey-haired as I am.
A lot of people don't really understand the contribution of carbon capture and storage to the energy mix, because we're not talking about necessarily how much energy can you get from carbon capture and storage. What we're really talking about is tackling climate change. You can say actually a pretty good solution for climate change is just to make sure that all the fossil energy you use gets used with carbon capture and storage. You can't carry on putting any fossil carbon in the long run into the atmosphere. The work we do here at Edinburgh covers a lot of different scales. We're running a large UK network that pulls together academics at all the universities working on carbon capture and storage in the UK. We're working on better ways to capture carbon dioxide, and most of all, we're training the people who will take that on, the next generation. We're seeing a need to develop UK's energy system, build it back up again, and we need to bring on the young people to do that. Behind me is Longannet Power Station, owned by Scottish Power. It's the largest power plant in Scotland, and it's likely to be the site of the UK's first carbon capture and storage demonstration. Longannet at the moment is putting out millions of tonnes of carbon dioxide a year, and all of that, or nearly all of that, could get taken away and put out securely under the North Sea. And what's actually really interesting as well, with power plants like this, you can burn biomass. Now the biomass has taken the CO2 out of the air. If you then put it back into the air, it's carbon neutral, but if you don't put it back into the air, you capture it, send it away, then you're actually taking CO2 out the air. So not only could you reduce emissions, you can actually go carbon negative. If we can get carbon capture and storage started, and started quickly, on power plants like Longannet, then we've got a reasonable chance of getting a good outcome in global climate change negotiations around 2020. Longannet's important because it's a retrofit project, but if we can get it done quickly, build up maybe 5 gigawatts of CCS in the UK by 2020, then not only will we cut our own CO2 emissions, but we're making a real statement for the world as a whole.
Buildings are about 40% of the UK's carbon dioxide emissions, and so they're one of the prime targets for trying to meet government CO2 reduction ambitions. A lot of our work is based on developing computer models of buildings, models which help us to understand how energy is used, the contribution which renewable energy technologies might make, and also models which can be used by central government and local authorities to develop their carbon reduction policies. If we have buildings which consume less energy, then the demand on the system is reduced, and renewable energy technologies, be it wind, wave, and some would say nuclear, has a much greater chance of meeting a higher proportion of our energy needs.
You simply don't get these new ideas coming through without giving scientists the space they need to think through new solutions. We founded Ceres Power in 2001. That company was based on more than 10 years basic science, fundamental research funded by the research councils here at Imperial College. During this research, we developed some new materials and new ideas by which we could apply these materials to produce a new type of fuel cell. The product that the company is launching in collaboration with British Gas for the UK market in 2011 will replace the boiler in your home. It will run on natural gas, and by generating electricity as well as heat for your home, it will save you energy. It will reduce the fuel consumption. And for a typical British home, it will reduce the carbon emissions by about 1.5 tonnes per year and save the homeowner around 1/4 off their energy bill. It's quite clear that we can make significant progress in meeting our near-term carbon reduction targets by deploying technologies we have available to us today. But if we're going to deliver the 80% cut in carbon emissions that the Commission on Climate Change tell us we need, we're going to need to develop transformational technologies. And if we're going to develop new breakthrough ideas, we clearly have to invest in the research that generates those ideas.
Marine energy can make significant contribution within the renewable energy mix because we have some of the most exciting, some of the highest and most accessible wave and tidal energy resources in the world.
Marine energy, I believe, will make a significant contribution to the energy mix for the United Kingdom, in excess of 10% of the electricity supply, and could be as much as 25% of the electricity supply.
The potential is very significant, not just in terms of energy production, but also in terms of wealth creation and intellectual capacity building.
Okay, so what we're going to do now is shut down the regular simple C that we're running just now, and we'll load up a more complex realistic.
The UK leads the world in terms of marine energy R&D right now. We have to maintain that position. There is an opportunity now to establish an industry that will operate in the UK, European and worldwide market, that will be able to develop a clean, lower carbon energy source from the sea for the future.
I think looking towards the middle parts of this century, I find it very hard to imagine that any one energy source will completely dominate the energy supply environment. I don't think we'll be in a situation we were in perhaps in the middle of the 20th century where coal was the largest producer. I don't think we'll be in a situation where wind power will be completely dominant, wave power will be completely dominant. I think we have to be considering an energy environment in which we will have substantial proportions of wind power, significant contribution from wave and tidal power, and of course fossil fuel, coal, oil, gas, and also nuclear will have their contribution to make. I think we need an all-energy solution.